Hi guys, it's Jason here again, and in this video we will try to solve another problem using nodal analysis in a circuit. In the previous example, we solved a circuit with two unknowns and we need two equations to solve them. And in this example, we will try to level up the number of unknowns. There will be three unknowns in this example, and of course, with that, we will be needing three equations to solve the unknowns. So again, the very first step that we should do in solving circuit in, like, say for example, in this example wherein we need to determine the nodal voltages of the circuit, the very first thing that you should do is to identify the nodes. So we have here node 1, we also have here node 2, and we also have here node 3, and of course our reference point here, our reference node. Again, there would be times when your reference node is not the ground, but for this example, but most commonly, it is the ground. Say for example, in this circuit, the reference node is your ground. Now we need to label this one as V1, V2, and then V3. So we need all this information for us to be able to redraw it to a simplified circuit. Again, I just want to emphasize that redrawing the circuit is very optional, but it is a very important step for you to be able to visualize what would be the possible equations that you will be needing, and also it will minimize your errors in having the processes using nodal analysis. So now let's go to the redrawing of the circuit. So first is we need to label our node voltages. We have V1, we have V2 here, and we also have V3 here, and then our reference node. Now we are ready to reflect all the elements in our circuit. For V1 and V2, we have our 3 ohms resistor here. So this is your 3 ohms resistor. Then you also have here your 7 ohms resistor between V2 and V3. Then V2 and your reference ground, you have your 1 ohm. Then you also have your current source between V1 and your Vref, or no, your reference node. You have here your negative 8 amperes, right? Then between your V3, you have your 5 ohms resistor. And in addition to that, you also have your source, your current source here. It's negative 25 ampere. What else? We have a resistor 4 ohms between node V1 and node V3. So you have here your 4 ohms, right? 4 ohms. What else? We have the current source between node 1 and node 2. We can reflect it here. The current source. We have here negative 3 ampere. Okay, again, the arrangement of each node, of each element in the node, is still up to you on how you would reflect them in your circuit, but see to it that the connections are correct. So let's check if we have reflected all of the important elements here. We have 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 elements in our circuit. 1, 2, 3, 4, 5, 6, 7, 8. So we were able to reflect all of the elements into our circuit. So now the next step would then be to label the current in our circuit. Okay, so for node 1, we have here, we can label this one as I3. So I'm using I3 because of the 3 ohms resistor, and it would then be easier for me to trace later because of the subscript. Then we could also put here our I4, right? Then our I7 here. We also have our I1 here. We have our I5 here, and then the negative 25 amperes. Okay, so after being able to write the current in our circuit, we are now ready to solve for the unknowns using KCL. Again, you would notice that there were three unknowns in this equation, in this problem. We have V1, we have V2, and V3. So expected that we would also be having three equations for us to solve the number of unknowns. So now let's use KCL at node 1. So when we say node 1, this refers to V1. Again, the current in is equal to the current out. Current in we have here negative 8. Okay, so I will not be reflecting the unit anymore, but see to it that the units all throughout your calculation is consistent. Like say for example, if the unit is ampere, then it should be in ampere, not milliamps. Same with voltage. If it's gonna be in volts, then it should not be in millivolts or microvolts. So just see to it that if you omit the unit, then making sure that all throughout the calculation the unit is consistent. So we have negative 8 here. Then we also have negative 3, which is equal to I4 plus I3. So we have 1, 2, 3, 4 branches at node V1. Then expectedly we should have 4 terms as well. So we have negative 8, negative 3, I4, and I3. So we have 4 terms. So we were able to reflect all of the currents in our circuit. Now let's express it into voltage form using Ohm's law. This will be negative 8 minus 3. Let's combine that. Negative 11. Then I4, your I4 is just equal to V1 minus V3 over 4 ohms, plus your I3 here is just equal to V1 minus V2 over 3. For simplicity of our calculation, we will transpose all of the variables to the left and all of the constants to the right. So we have here V1 over 4. We also have here plus V1 over 3. We also have here V2 over 3. And we also have here V3 over 4 is equal to negative 11. Now we are ready to combine like terms so that we could simplify it further. There were 2 terms for V1, so that would be 1 over 4 plus 1 over 3, which is then equal to 7 over 12 V1. Then we have 1 term for V2, so that's going to be V2 over 3. And 1 term for V4, that's V3 over 4. V3, 1 term for V3, so that's going to be V3 over 4, and then is equal to negative 11. This will be our first equation. Again, we need 2 more equations to solve for the 3 unknowns. As you notice, we have V1 here, V2, and V3. So we need 2 more equations. And how are we going to do that? We need to apply KCL at node 2. So we are referring to the voltage V2. So in KCL at node 2, we have I in is equal to I out. I in for V2, we have I3 here, and we have I3 only for I in. And for the I out, we have negative 3. We also have plus I1, and we also have plus I7. So let's have its voltage representation using Ohm's law. I3 is just equal to V1 minus V2. Again, v2. This is v2. Again, remember that you have to express it. It's gonna be tail minus the head of the arrow. So tail would then be v1, head would then be v2. Okay, just make it consistent all throughout the calculation, then you're good. You will be able to eliminate errors, confusions, and future mistakes if you will just be consistent with that. v1 minus v2 over 3 equals negative 3. You have your I1 here. Your I1 is just v2 over 1. Your I7 here is just equal to v2 minus v3 over 7. So this will be your equation for node 2. Then again, we need to transpose all of the variables to the left and all of the constants to the right. So in this equation, we can notice that there is only one term for v1, but we have three terms for v2. So we have here v1 over 3. We have minus v2 over 3, right? Then we also have minus v2, and we also have minus v2 over 7. Then we will reflect the v3, so that's going to be v3 over 7 is equal to negative 3. So this is your second equation. But first is we need to combine like terms. We have three terms for v2 here. So we have v1 over 3 minus the term for v2. We have negative 1 over 3 minus 1 minus 1 over 7. So that would be negative 31 over 21 v2 plus v3 over 7 is equal to negative 3. This will be your second equation. So we still need one more equation to solve our circuit. So we will be able to do that by having KCL at node 3. So that would be at node V3 rather. So summation of current in is equal to summation of current out. For your current in, you have your I1. You also have your I7 here. Then is equal to I5 plus negative 25. So that's going to be negative 25. So 1, 2, 3, 4, 1, 2, 3, 4. So your I1, again, tail minus head, you have V1 minus I1. You have at node 3, you don't have I1. This is not I1, this is I4, right? So this is gonna be I4 plus I7, right? So I4 plus I7 is equal to I5 minus 25. So that's it. So I4 is just equal to V1 minus V3 over 4 plus your V3 here. Your I7 here is just equal to V2 minus V3 over 7 is equal to your I5 here is V3 over 5 minus 25. Okay, so this will be our equation for our third node. Now, let's observe that there would be three terms for V3, one term for V1, and one term for V2. So we will just be combining the like terms. So we have V1 here over 4 minus plus V2 over 7. So minus V3 over 4 minus V3 over 7 minus V3 over 5 is equal to negative 25. Then we will just combine like terms. We have here V1 over 4 plus V2 over 7. Then for our V3, we have negative 1 over 4 minus negative minus 1 over 7, right? Minus 1 over 5. Okay, so that would then be negative 83 V3 over 140. Then equals to negative 25, and this will be your third equation. Now we were able to find the three equations that we will be needing to solve for the values of v1, v2, and v3. So we now write all those equations here. Then we will use our calculator to solve for the values. So for equation 1, we have 7 over 12 v1 minus v2 over 3 minus v3 over 4 is equal to negative 11. Our second equation, we have v1 over 3 minus 31 over 21 v2 plus v3 over 7 is equal to negative 3. And for the last equation, we have here v1 over 4 plus v2 over 7. Okay, where is it? v2 over 7 minus 83 over 140 v3 is equal to negative 25. Okay, so this will be the system of equations that we will be using to solve for the values of v1, v2, and v3. Okay, so using your calculator, in the previous example, we used mode, then 5 for equation, then we chose 1 because there were 2 variables only, v1 and v2, but in this example we have 3. So instead of choosing 1, we need to choose 2 that would then be similar to the format that we are currently facing in this example. So we will choose 2. Now the only thing that we should do is to input the numerical coefficient of the equations. So for equation 1, we have 7 divided by 12. We have here negative 1 divided by 3. We have here negative 1 divided by 4. And then we have here negative 11. We also have for the second equation, which is then 1 divided by 3. Then negative 31 divided by 21. Then 1 divided by 7. And then negative 3. For the last equation, we have 1 divided by 4. 1 divided by 7. And negative 83 divided by 140, and then negative 25. So all you have to do is to press equals. Then you will have your value for your v1, which is equal to 720 over 133 volts, or just equal to 5.41 volts. For your v2, you have 147 over 19 volts, which is just equal to 7.74 volts. And for your last variable, which is v3, you have here 880 over 19 volts, right? You have 19 volts. Then that would then be equal to 46.32 volts. Okay, so there you go. You have your answers for your node voltages for this problem. So all you have to do is to follow the steps that I have mentioned in this example, and then you will be able to solve similar problems.